since. So it's a pleasure to be here today. Apologize as a moderator, really awkward keynote speaker, and the follow-on Ministry of Environment speaker aren't here yet. And so I'm encourage you to take notes and questions when they do arrive. Purpose of this talk that I'm going to talk on background groundwater. Many of you are aware that there were issues last fall with the omnibus changes in our standards. So the contaminated site regulations were completely overhauled with respect to the numeric standards for soil and groundwater. And the follow from that process was that several metals that didn't used to be a problem suddenly popped up on contaminated sites as a problem. And you'll see as we go through this, but some of the key ones in particular are lithium and cobalt, and some others as well. This lithium one is a bit of an odd one. A colleague of mine informs me that some of the road salt used in British Columbia is actually the non-sodium chloride, I guess it'd be calcium chloride based, is sourced out of places in the US which have lithium as the co-contaminant that no one ever worried about. So now with really low standards, and the labs are always getting better at standards, by the way. They can lower the detection limits and ramp things up. These things that never used to be an issue have become an issue. And so with the background groundwater, then it turns out many sites. As a matter of fact, I believe we estimated that half of the sites in British Columbia would naturally exceed the lithium standard, if I recall correctly. So I'm pretty sure several people in this room are aware of properties that suddenly went on hold with these new standards. And the way around it is to see if we can agree on a background value that's much higher than the actual new standard. So that's the process that's happened here. And so in BC, if you have groundwater at a site that has a substance exceeding a standard, your site becomes legally contaminated. This is kind of a big deal in Canada, actually, because I've done a lot of work in other provinces. And while they may have criteria, they're usually careful to call them criteria and not standards. In British Columbia, if you have a site that's over that number, you're legally contaminated, and you can't get out of it. You can remediate and bring it down, bring the number below that standard, or you can get a risk-based certificate, meaning it's okay to be above that standard, but this stigma of contamination remains. And it provides the government, as I understand it, with quite a bit of power to deal with situations where there's real problem sites. So, but the contaminated site regulation also recognizes that if you have a site with a background value that's over the standard, then the background can be used as the default site-specific standard, and your site is not a contaminated site. So this is a big deal. So for background, we're talking about naturally occurring things like lithium, which were already in the soils, natural soils in British Columbia. Maybe with the ice, through the ice age, the till ground up some mineralized areas of the province and spread it all around. And it has nothing to do with people or anthropogenic sources of contamination. It's just there naturally. It's in the background. So if we can establish that, then why should we have to spend a ton of money drilling holes to prove that we have background? Is there a way we can just go to a chart and say, oh, I'm in an area where lithium is recognized as a high background, and I don't have to worry about it? And that was the driving force here. It's unfortunate the process started, I think, last March 2017 to try and identify background groundwater. And as we'll talk about shortly, it's not trivial actually to come up with these numbers. So in British Columbia now, there's a protocol to determine background, Protocol 9, which you go through a process to come up with a background number for your site. But now we have this Technical Bulletin 3, which has actually taken a few areas of the province where we have data and come up with background numbers. So this Protocol 9, I remember talking with Ministry of Environment a few years ago, because we recognized there needed to be a process for coming up with background for a site. But the process that was derived has some requirements. It has to do with building a conceptual model for the site, but at a minimum, the protocol says you need to put in at least 3 background wells, and they have to be installed in areas that are not influenced by anthropogenic activity. So in other words, you should be avoiding areas that have fill. And really, how many sites in urban environments don't have some fill on them? And even when you're in remote areas, finding background wells is a challenge if you want to stick to your property boundaries. And then if you have to go off your property boundary and you got to start talking to neighbors, not many of us want to do that. I mean, so it may sound easy on paper, you got to have 3 background wells, but implementation has always been a challenge. If you stick to your site, then you have to, if you're very clever about it, maybe you'll get lucky and find that 3 of your wells can be classified as background, but that's not so easy, especially in some of the more contaminated industrial properties. It's hard to even come to that conclusion. And then when you put your wells in, you have to sample the wells at least a couple times, and there's a good reason for that. Concentrations vary seasonally, you know, wet season, dry season. Hydraulic gradients can change a bit. And then the next part of the protocol says that if you have enough data, you should calculate the 95th percentile, which is a statistical number, meaning you're going to err on the high side. So you're trying to come up with a reasonable number, but high, so that the standard you come up with, you're likely to be below your site-specific standard when you have other wells on your property. It sounds easy, but when you only have, you know, I'm not a great statistician, but I'm pretty sure taking 3 data points, sampling twice, and calculating a 95th percentile, statistically, most of my profs at university would tell me to go get stuffed. So that's just not how you do it. Ryder's probably taught some of these courses, and he'd probably be the first to tell me, are you crazy? But anyways, this is what we're stuck with in BC. So this protocol 9 also can define, you have to define the hydrogeology and geochemistry of your site. And by building this conceptual model and putting together a proper story, I think the ministry, and you can't quote me because Steve Dankevy isn't here, but he goes more lenient on the requirements of protocol 9 if you've got a conceptual model that demonstrates science-based demonstration that you really do have background. I think there's been some leniency there, but the reality is protocol 9 is now under review. We got to come up with a better process, but another reason for it being under review is that this technical bulletin I'm about to talk about is going to bring in these regional background standards so that it'll be incorporated in tables into a proper protocol. So here I just mentioned that in March 17, the Contaminated Sites Approved Professional Society, they flagged lithium and cobalt as issues with the upcoming new standards. Different consulting companies, there was 3 in particular, I think, Hamer and SLR, I think maybe Golder and a couple others, they were involved with through, you know, scanning their databases with the new proposed standards, and they said, hey, there's going to be a problem with lithium, there's going to be a problem with cobalt, maybe others too. What should we do about it? So the process began there to try and figure out, well, if we go through all the data and come up with some kind of procedure, we should be able to demonstrate background. It's easy to say, but man, what it triggered, we'll talk about, is quite a process. So when November 1st rolled around and the new standards became promulgated and enforced, lithium became an issue because it didn't used to have a drinking water standard. And now through this risk-based process, there was a new number, and I believe it was like 1 microgram per liter or something. Cobalt, it had a new low standard of 1 microgram per liter. Previously, I think there'd been an email which issued by the Ministry of Environment Director that said, hey, this is back in 2002, they issued an email saying, we're gonna make the province background 20 microgram per liter. We have enough information to think we can do that. But that email and that directive was no longer enforced as of November 1st. So now suddenly cobalt was back on the table. And for those of you that have done work in the Lower Mainland here, anywhere in the Fraser Valley, in the Fraser River Sands, where you've got, we'll call it, you know, as a geochemist, an anoxic environment, low to no oxygen, arsenic, naturally occurring mineral in the soils. This is a ripe area for arsenic to actually enter into the groundwater system at concentrations much higher than applicable standards. So arsenic has always been an issue in the Fraser River Sands and Salish sediments around here. And the drinking water standard, while it remained at 10 microgram per liter, was still kind of too high as far as background goes. something I'm going to throw this out here. When Heather gets here, I got to ask her about it. But you know, arsenic, most of our standards are set, the carcinogenic ones are set at to try and protect us from a 1 in 100,000 chance of getting cancer if you consume this stuff. And arsenic being a carcinogen, that's one of the reasons the standard's gone. I mean, when I started in Saskatchewan, it was 50 microgram per liter. The groundwater in Regina had 30 and everybody's okay. Now we're saying 10 is okay. But if you talk to the toxicologist, 10 ain't okay. 10 is like, I think it's like 1 in 10,000 chance of getting cancer. It's not 1 in 100,000. It starts getting actually real and significant. And that number is set at 10 because if we had to bring it down to 1 or less than 1, our water treatment plants throughout the province no one could afford the treatment to bring it down that way. Just a little bit of an aside. And then these other compounds, selenium, vanadium, and uranium, I don't think not sure if the standards changed for those guys, but they have low standards in water. And there's areas of the province, and particularly in the Thompson-Okanagan region, where these things pop up over standards all the time. So there was a need to say, hey, can we just take all this existing data and come up with a background number, and so we don't have to waste a lot of time and money proving that we've got background. So that was what's driving it. Here's the lithium value in the new standards. So there's the new drinking water value of 8 microgram per liter, and before there didn't used to be one. So what happened? The process that was gone through, this is the stepwise process that's actually written out in the technical bulletin 3, canvassing the data sources and compiling a database. So that actually started back in the days of CSAP in March, going through with consultants and finding out about the data they have and pulling together all the available data. There's also, you know, there's data available from federal government, there's data from municipal water supplies, there's data on the contaminated sites database that are part of the site registry, all the reports that consultants have sent in to get certificates and other numerical instruments. So there is a lot of data that's out there. Then the question was, we have to take this data, but we got to filter it so we actually know we've got background. And that was a bit of an issue in that the filtering process is not trivial. If you want to demonstrate based on, you know, pull out a consultant's report, especially if you're going through hard copies of heaps and heaps of information, you need to satisfy yourself that the chemistry from that particular well really was from part of the property that wasn't influenced by anthropogenic sources. The screen interval wasn't cross-communicating between different groundwater systems. The sampling was done appropriately. The detection limits of the metals were okay. There's a whole host of things that you have to go through. And so while it was easy to say, it wasn't easy to do, and it took a fair bit of time. So in addition to setting up filtering criteria, you had to understand the geology and stratigraphy of an area, because geochemistry in groundwater it's not like surface soils that got spread around by the glaciers. We're talking about separate zones where you can pull water out of an aquifer, and that aquifer there may be multiple stacked aquifers. Who's to say that the geochemistry in the shallow zone is the same as the deep zone? Or if you move over 50 or 100 or 200 meters, you're not in a whole different groundwater system. So all that had to be looked at. And then once the filtered data were made available, then you could start running statistics if you had enough data to do that. And then from the statistics and the geology, then you look at, can I actually define a region where we can apply this background? And so that took a fair bit of thinking. And then finally, once all that was set, push the button and out pops the number. So in this process, data were examined for, to start off with 5 regions. We're showing here the lower mainland, southern Vancouver Island between Nanaimo and Victoria. And of course, this is because that's where most of the data are, most of the issues with contaminated sites are. Thompson, Okanagan, Prince George area, and Northeast BC. The Northeast BC around Fort St. John and Prince George area, by the way, as well. I don't have the data set because this meant that lies with the ministry. But after all the filtering process, there was something like around Prince George area, they were left with, I think, four actual locations that they could use for background. That's not enough to run stats on. It was just similar for the Northeast BC, at least for the data that were made available. So those two regions don't have background values yet. It's not to say it's not going to happen. The data sources used, as I mentioned, there's existing studies. There's provincial wells data from the water supply aquifers. Ministry of Environment has a site database, including approvals for background. Those are obvious place to go, but there's not a lot of those actually. Determinations, meaning if wells were put in to come up with a conclusion that there's no contamination, there might be good background data there. But the biggest one I've highlighted here is certificates of compliance. That was the biggest data source in this whole data mining exercise. So all the certificates that have been issued by the province were reviewed and mined for the data and then filtered to come up with reliable data sets. There is a lot of data rests with the federal government, I understand, but that wasn't made available in time to get this technical bulletin out the door. So there's still more data to come, I think, from there, which could be used in future. Another issue on the drinking water aquifers, most municipalities that actually have wells stuck in the drinking water aquifer, if you look close at that data, many of these municipal supplies, their water is really, really good quality. And if we used municipal data to come up with the background, we'd actually have very low standards. And that's not, so what's wrong with that? Well, it doesn't get us anywhere. But the other issue is that when we deal with contaminated properties, the aquifer might be down at 50 or 60 meters down there, and we've got an industrial property that's caused some pollution in the upper 5, 10, 15 meters, and that's where we put our monitoring wells, in some little thin sandy zone where we're able to get more than 1.6 liters a minute of water out of it. And so that shallow water is seeing the influence of for example, the tills that the ice age slapped around the province. It's got all the weird mineralization, and the background in that water is going to be much higher than what we're seeing in the downstairs. So as a matter of fact, most of that municipal water, that data is great data, but I think there was a decision not to use it in the assessment because it would get us all in a heap of trouble. And by the way, I noticed Heather Osachoff is from the ministry has showed up, and much of what I'm saying here, I took from Heather. She may not know it, but I watched her presentation last June, and I've got very good notes. So if I'm saying anything wrong, I'm hoping Heather can correct me either while I'm talking or at the end. Please feel free. So in the data quality issue, as I said, it's not just about the chemistry. There's issues around detection limits when you're going through old data. How good were the logs? How good are those borehole logs for that well that was put in? And if, pardon my rant, I like ranting here, but when I pick up some old reports, some consultants, it's amazing the level of detail you can see in a borehole log, and others, sand, blue clay, hard pan. So what do I do with a log like that? You know, and if they've got it, you know, anyways, you have to look carefully so you can say, is this data actually reliable? The business about detection limits, and I know we do have people from Caro Labs here, so we could ask them the question, but I'm pretty sure I'll call the olden days from the 1990s, detection limits for lithium, cobalt, selenium were probably a lot higher than they are today. Technology's improved, the labs are getting better at what they do. So I believe there was almost like a cutoff, and it wasn't a hard cutoff, but anything before 2011, that data for these trace metals is pretty poor. And so we've got, you know, I'll call them hundreds of certificates issued for sites where the detection limits today are too high. So that eliminates a whole bunch of data off the table right there. Most contaminated sites in groundwater are shallow, as I mentioned. They're an overburden in till and not necessarily an aquifer. So there is the issue around data quality. So technical bulletin 3 sets background levels only for the following substances. There's arsenic, lithium, selenium, vanadium, uranium. Cobalt, as we'll see in a few slides from now, there's a province-wide background. There was a memo came out saying that email back in 2002, we're gonna use that, we're gonna put that back in force. So whew, cobalt's now gone from 1 back up to 20, and I think for many of our sites, it's off the table now, in that we don't have to worry about it. course, the caveat is you happen to have a site that has 25 microgram per liter cobalt, you're kind of hooped. And then you've got to go back, you know, if you think you're over background, you've got to go back to the P9 process and put in the proper wells and go through the process. There's no way around that. So the applicability, these new groundwater values, they're not applicable to bedrock. And for me, that's a big deal. I live on Salt Spring Island and my well's 100 meters deep in bedrock. And thank God, I don't think I got the lab to run lithium on my water well. Maybe I'm toasting myself. My arsenic is coming in at like 9.2 microgram per liter. That I was happy with that until I realized that even that is still not actually very good from a health standpoint. Anyways, so no bedrock, so even large chunks of the city of Victoria, and I mean the whole southern Vancouver Island, we've got the overburden aquifers, but so many wells are actually in rock, and this doesn't help you. Not applicable to surface water. There's probably obvious reasons for that, but and the site has to be it must fall in these geographic boundaries, which I'll show in a second. So what are the numbers? So we now have numbers. You know, download Technical Bulletin 3. I just did screen captures off of that. So you can see, for example, in the lower mainland, this is in the Fraser Valley, the Fraser River Sands, arsenic, you know, drinking water usually applies, although not many people drink water on the Fraser River Sands, but the standard is 10, but the new background for the lower mainland is 37. Lithium's gone from 8 to 28. As far as selenium, uranium, vanadium, you don't get any relief in the lower mainland for those. And then outside of the Fraser Sands, we're getting into the overburden in downtown Vancouver and towards the North Shore Mountains. The background arsenic it's still bumped up, but not as high. It's only 13 as opposed to 10. Lithium's only 19 as opposed to 8. And now vanadium pops up. I have no idea what vanadium's even used for. Is it in our microchips or something? Anyways, Thompson Okanagan did get a lot of relief for the selenium, uranium, vanadium though. You can see from the numbers. Look at lithium, 96 is the new background as opposed to 8. Selenium, 107 as opposed to 10. And uranium's bumped up and vanadium. Interesting. And then in southern Vancouver Island, the only relief again is in this lithium value, 33 as opposed to 8. So the technical bulletin, I'm going to try this. I'm not sure it's going to work. I was trying it earlier. And see what happens here. I don't think I'm going to be able to get it to work. Let me dismiss some of this stuff here. Okay, it's gone. Everything's gone. This is exactly what I feared was going to happen. Hey, Ryder. Let me put my presentation back up and see if I can get this going. So the point is, there's these maps. You click on them, and even with the Wi-Fi in this room here, you got to wait a while. It loads up a map, links to the provincial website, and you can see if your site falls into the zone or not. The problem with these maps is that they're not very high resolution, so I'm sure there's someone at the ministry that's going to figure out how to make a better interface for people that have to use these maps. But you can imagine, because they're not that high resolution, if your site is anywhere near a boundary, you can't just, although the technical bulletin says you can rely on these maps, you could get yourself in a whole heap of trouble. There's good geologic reasons why, for example, there's a boundary between Fraser River Sands and Vashon Drift. That's sort of the cutoff over much of the Vancouver, Burnaby, Lower Mainland area. And if you're on a property that only has Vashon Drift and there's no Fraser Sands, but the border line may actually, it isn't real clear if your property, which standard should apply, the geology will be the answer. And all I can say is that some of those borderline sites, unless we get a more refined map, you might actually have to punch a hole in or look at the geotech logs or something to make the final decision about which standard actually applies to your property. hopefully that's not going to be too common. So there's there's the two lower mainland regions, the Thompson, Okanagan, so the Kamloops and Kelowna areas, and that's where most of the data are from. So that's where that's coming from. And then South Vancouver Island is from Nanaimo down to Victoria. So you just have to click on the map. And if your property's outside of these regions, right now in BC, you got to do Protocol 9. And you know, the first, I remember talking to someone up in the Terrace area, northwest BC, and the first question to me on the phone was, what about my area? I got lots of the groundwater data. I said, yeah, sorry, but you might have a lot of groundwater data around your little community, but we're talking about regions of the province. And when you add it all up, I'm guessing you only got 3 or 4 good wells that we could call background. So we don't have enough to actually do something for Northwest BC, but it doesn't mean it won't happen. It's just we aren't able to do it yet. The other factor is that in addition to having enough data, this takes time. It took several months with a couple people from a consulting firm working with the Ministry of Environment, like full time, going through reports and pulling together the data to come up with these numbers. So it needs resources. So on that note, then, as I said, it needs resources, and that's a question you can put to Peter Kickham and Heather Ossichoff about how many resources are available these days at the ministry. But the background issue is not going away. I mean, it's useful. It's going to save us all a whole heap of trouble in the long run. The whole concept of having maps for the province for our business contaminated sites, in my view, it's the way to go. As data are acquired, we can improve the maps and improve the boundaries and save a whole pile of time drilling holes, you know, to deal with a small property when we've got all this information around from a science base just makes no sense. So mapping things out and coming to some conclusions about background is the way to go. So that's great. And then the idea is this will all get back into Protocol 9. So with that, I'd like to, I can try answering any questions, and believe you me, if there's many, I'm going to direct them over to Heather and Peter. Yes. Oh, well, sorry, Jim, we'll do about this one here first.
No, it only works for the recording. So
it's just for the recording. I'll be able to hear you.
Thanks, Guy, for that overview. That was very interesting. A question I have, and this kind of goes back to the old days or whatever, and one of the things was, look, why are we testing for certain things if it's not associated with our site? If we can't figure out that I don't have a lithium source, I don't have a uranium source, and you know, so, and I remember it was he's now retired, somebody at the ministry was very adamant, look, if it's not an APEC associated with your operations, don't test for it. Now, have things changed? Like, if with this background awareness and all this, I mean, have things gone to where people are now testing everything for everything just cause, or do we find that we are still putting boundaries on what we're testing for and why? You know, like a good example might be is if I know I got a site in an area where there's high lithium or high background, do I consider that like an offsite APEC, you know, in a way, or what's the perception of that? Anyways, I think you can see, like, where's, like, are we far, what's the feeling about, are we getting caught in having to argue all these background things because we're testing for things that we probably shouldn't have to be testing for, you know, fundamentally that are, you know, potentially contaminated?
Well, I know that's an excellent question, and I can give my own personal answer from experience. So I'll give you a couple different perspectives. Number one, I'll never forget when Glenn Fox said, if it's not one of your concerns, don't. He said, if it's not a concern, don't test for it. I thought, sure, that makes sense, right? Lithium, yeah. Man, unless you're running around throwing lithium batteries around your property, why would you be testing for lithium? Although I will say, though, that other example I gave earlier on this morning about if you're using some you know, non-sodium chloride road salt that happens to have a lithium contaminant in, maybe you should be testing for it. So you do have to do a bit of work there. The other thing about these metals, there's several metals that actually, they may not be contaminants at your site, but if you have a petroleum hydrocarbon and you turn an aerobic oxic environment into strongly reducing anaerobic, you can mobilize a lot of metals, slight change in pH, redox potential. So I'm not sure about lithium, for example, and we probably could use some guidance, but there's some metals that maybe have nothing to do with your site, but you caused contamination indirectly, and then they do become contaminants of concern. So you have to understand that part. So I'm with Glim Fox though. This whole background thing has gotten a lot of people in a whole heap of trouble, and it's still common. When you send in a sample, you say just run a metal scan, you know? So what's the lab going to do? Of course they'll run a metal scan. So they're going to give you lithium, they're going to give you cobalt, they're going to give you all this stuff. And if you didn't want it and that gets you in trouble, you kind of who, because facts are facts. So that's an issue. On the other side though, I will say that my years of experience, I love having all kinds of data because I look for patterns and trends and concentrations. And something like lithium, this is a bit of an aside there, but if I see concentrations in an aquifer that have some kind of continuity, I can actually use that data to help me understand recharge areas, where the groundwater is discharging, how that system's flowing. You put together the geochemistry without even dealing with your contaminants of concern, and you can build your conceptual model. So I'm a big fan of having all that data, but this, I'll call it the political dilemma, just gets you in trouble. So.
And it's expensive to get the data.
Well, it can be. Trust me, back compared to the old days, this metal data is kind of cheap actually. It's some of these parameters compared to the old days, we're getting it for a song and a dance. But we can. Carol Labs is here today. You're welcome to ask them about their pricing. But I'm surprised how inexpensive it is. But that's a different story. If Peter and Heather had any more comments on that, welcome. Okay, I'm going to put in a plug on Contaminated Site Approved Professional Society. We've got a guidance document that's been put together. It's available on our website for, I think it's for everybody, it's certainly for approved professionals, but we've tried to identify what are the contaminants of concern for different uses, Schedule 2 uses. So I think it'll be a big help actually. And if you follow that, it gives you justification for not dealing with lithium at your gas station, for example. We have another question there, Jim?
Yes. Hello. I don't know whether you can answer this, but it's one of my favorite pet peeves. Would the outcome of this background determination within the province actually prove that drinking water does not apply in certain areas? City of Richmond, for example?
Yeah, if you thought that the lithium or selenium are going to toast you, you shouldn't be drinking the water anyways. No, I mean, I'm just going to say, we have water treatment technologies you wouldn't believe can take stuff out of water supplies. You know?
But you can apply that to anything.
Yeah, you can. So I'm not going to go into that. Oh, there's one more question over there. And then I think after this question, we're going to move on.
Hi.
Yep.
I actually did have a question in with the ministry, trying to get some clarification on some discrepancies with the Thompson-Okanagan region that's listed in the technical bulletin.
Yep.
So the bulletin starts by saying that it's the area between Kamloops and Kelowna, but then the maps are a little hard to understand because it shows one map for the Kelowna region, one map for the Kamloops region, and then a bunch of yellow stuff in between in the little inset. It's not clear if those yellow areas are included and where exactly they are, because there's no roads or highways or anything shown on the map. So I've been trying to clarify, and I think Steve Dankaby or Annette were going to be calling me back next week to let me know if all the areas in between are included or not. I don't know if anybody, Heather or
last time I
would be able
talked to Steve, he said he's working on it. Because he said that is an issue. The map isn't very clear for the Thompson-Okanagan.
Not at all.
And they've got to put some effort into fixing up the map. That's what I heard 2 weeks ago.
And of course, the wording is contradictory because one says it's the region between the two, and then the map doesn't necessarily clarify the region between the two. So
that's correct. I think that's correct. It wasn't very good resolution between the two. So that's a good pointing out, and I think they're working on it, but.
So no answer yet.
Okay, thanks.
I'll talk to Steve on Monday. Thanks.
So